Hey, what's up, guys? Hey.
Relate the ability of the material to block, absorb, or transmit light to its use. Hello guys, this is Sir Boyet and welcome to my channel. Important questions. 1. How light interacts with different materials. 2. What materials can reflect, absorb, and transmit light? 3. How color of an object affects its ability to absorb heat. 4. What are the uses of materials that block, absorb, or transmit light? Have you ever tried watching the sunrise in the east while inhaling the morning breeze? How beautiful is it to observe the flowers that the colorful butterflies are landing on? And the color increased even more as the sun set in the west. The shadows of the colors seem to draw on the surface of the seawater. It is very beautiful to observe the brilliance of the moving waves. What does sunlight have to do with the beautiful things we see around us, like rainbow? The colors in the sky are beautiful, especially when there is a rainbow. No one can stop admiring it. When colors of light are separated due to alteration of water droplets, these colors are very visible in a rainbow. A rainbow appears in the sky as a result of the reflection and refraction of white light from the sun as it shines through the water droplets in the atmosphere. The water droplets act as prism that reflects, refracts, and then splits the white light into an arc of visible colors of light, as seen in a rainbow. Sunlight is a combination of different colors. We can see the different colors of visible light using a prism. A prism is a transparent optical object with flat surfaces. It can be used to reflect light, breaking it into different colors of the rainbow. Light can be blocked, absorbed, or transmitted by certain materials, and the color affects the ability of a material to absorb heat. Today, we will find out how light affects the beauty of the things we see around us. 1. How light interacts with different materials. Have you seen artworks on a stained glass? Stained glass are seen in churches, museums, and even in some houses. The design on stained glasses are achieved through the use of glasses with various colors and hues. The light that partially gets through stained glass highlights the different colors and the hues, making them a sight to behold. While light partially gets through a stained glass, some materials, like a wooden door, do not allow light to pass through them. There are also materials, like the clear glass windows, that let light shine through them. What is visible light? The light that is visible to the human eye is called visible light. White light from the sun is a combination of different colors. The visible light is only part of the electromagnetic spectrum, AM. The AM shows the entire range of waves present in our world. Colors are really various frequencies of light. Colors are ranked according to their frequency. We can have this order, Roy G. Beeve. Therefore, we can say that red light with the lowest frequency has the least energy of the visible spectrum. The primary source of visible light is the sun. The visible light allows us to see the color that is not absorbed by the objects. For example, we see most plants as green because the leaves absorb all colors of the visible light except for green. To understand light further, we have to study how it interacts with different objects. This branch of science is called optics. Optics is a study of the refraction, reflection, absorption, and transmission of light. What is refraction? Refraction refers to the change of direction of a ray of light, heat, or sound when passing from one materials into another. The bending of light as it passes through different materials is also called refraction. For example, the pencil in a glass of water appears bent because of the different part of the material that interacts with light. The part of the pencil that is not deep in water interacts with the air, while the part of the pencil dipped in water interacts with the water. Light moves faster in air than in water. This is why the pencil looks bent. What is reflection? Reflection is the opposite of absorption. When more light or heat energy bounced, reflection refers to the bouncing back of light when it hits an object. It means that the light heat return after striking a surface. It is simply reflected off. Some objects with flat surfaces, like mirrors, reflect light in a straight, predictable way. Some objects with uneven surfaces, like rocks, reflect light in a scattered way. Reflection happens when the light that hits an object is bounced back by the object. When we see an object, what we are seeing is the reflected light. What is absorption? Absorption refers to a material taking in of light and not reflecting it back. For example, when light strikes a black surface, it is absorbed by the surface and nothing is reflected. When light hits an object, some parts of the light absorbed by that object and some are reflected back. Absorption happens when light gets through the object. Different objects absorb heat at different rates. Some objects are excellent absorbers, while others are very poor absorbers. Absorbance is the ability of a substance to absorb light or radiation. Generally, dark-colored objects absorb better than lighter-colored objects. Dark-colored look dark because they absorb more light. What is transmission? Transmission refers to the passing of light through some materials. For example, when light passes through a glass window, it is transmitted to the other side, allowing the light to pass through the window. What are the different materials that have different ways of transmitting light? 1. Transparent materials allow all light to pass through them. Clear plastic and glass windows are examples of transparent objects. 2. Translucent materials allow some light to pass through them. Stained glasses and frosted windows are examples of translucent objects. 3. Opaque materials do not allow light to pass through them. Concrete walls, wooden doors, and mirrors are examples of opaque materials. Opaque, a material which cannot be penetrated by light, resulting in complete reflection. How do we see objects in different colors? How does a colored material affect its ability to absorb more light? Well, the answer is simple. What we perceive as color is really different frequencies of light. So the color of an object is not contained within the object. The color is the result of the light which strikes the object and is reflected by it. White light is actually the combination of all the frequencies of light. When we see a red object, it means that only the color red is being reflected by the object. A red shirt absorbs all the colors of light except for the red color. All the other colors are absorbed by the red shirt. Black and white colors are different from other colors. White is a combination of all the colors. When we see a white object, it means that the object is reflecting all the colors of the light and at the same time. This means it has all the colors in it, and because it has all the colors in it, white colors reflect light. Black, on the other hand, is the absence of reflected color. When we see a black object, it means that the object is absorbing almost all the colors of light and none of the visible colors are reflected. Generally, dark-colored objects absorb better than the lighter-colored objects. Dark colors look dark because they absorb more light, making them harder to see. How do colors affect the heat absorption of an object? Do you know that the amount of heat an object absorbs depends on its color? A simple way to measure how much heat a colored material produces is to measure the changes in its temperature. Since black is the absence of all colors, it does not reflect any of the colors but rather absorbs all of them. Black materials have the tendency to absorb all light frequencies. The absorbed light energy is transformed to heat, which makes black materials hot. The more colors an object absorbs, the more heat an object is generated. The more colors an object reflects, the less heat an object is generated. Thus, objects that absorb more colors of light also generate more heat, making them hotter than the things that absorb less colors or reflect more colors. When a colored fabric absorbs light, it turns the light into the thermal energy heat. The more light the fabric absorbs, the more thermal energy it produces. When the weather is warm, which do you prefer, wearing light-colored clothes or dark-colored ones? During summer, clothes in light color like white, pink, and yellow are more popular. White is the presence of all colors. White therefore reflects all the colors and does not absorb any of it. White objects reflect all wavelength of light, so the light is not converted into heat and the temperature of the object does not increase noticeably. The less light is absorbed, the less heat is generated. So during warm days, it is wise to wear white because it absorbs less heat and is more comfortable to wear. So, when the weather condition is warm, children should wear white or lighter colored shirt when playing. Meanwhile, black fabric absorbs all the colors of the light and is therefore warmer than white fabric, which reflects all colors. In black or dark objects, more colors of visible lights are absorbed, and since more light are absorbed, more heat is generated since light is a form of energy. So, clothes with dark colors such as black, gray, and maroon are preferred during cold weather. When a colored material absorbs light, it turns the light into heat. The more light a colored material absorbs, the more heat is produced. The colors of the spectrum, appearing the darkest and most like black, violet, indigo, and green or brown, will produce the most thermal energy. The other colors, red, orange, and yellow, will produce the least thermal energy because they appear lighter or more like white. Question: what do you think the coldest and the hottest star would be if you observe the color of light from its star? Red stars are the coldest. Yellow stars are hotter than red stars. White stars are hotter than red and yellow. Blue stars are the hottest stars of all. What are the uses of materials that block, absorb, or transmit light? 1. Choice of clothing. Materials that block, absorb, or transmit lights has many uses. They can be used as colored designs for our clothing. Black or colored materials absorb light, while the lighter or white materials reflect light. Lighter color is better on the hotter days to make you color because all lights are being reflected by it. While darker color is better suited on colder or rainy days to make yourself warmer as it absorbs all light frequencies. 2. Robotic competition. In robotic competition, a simple robot makes use of reflected infrared light to detect their opponent. So usually robots are painted black or white. 3. Sensors. Door sensors automatically opens when one person gets near a bit. It uses infrared rays or IF. It works by emitting and then measuring the intensity of light that is reflected back from an object or material near it. 4. Heat insulators at home. The emergency blankets that are used to protect a person when he is exposed to freezing temperature can be used to block heat from the outside. Did you learn a lot today? See you again and thank you very much for watching. Subscribe for more videos.